This is activity 1. What could the graph represent from lesson 11, interpreting graphs of proportional relationships? And in this activity, you're given a graph. There is one point on the graph that's plotted. There's a line that's drawn. It's a straight line through 0. So this is a graph of a proportional relationship. And given this point here, if you take 8 of whatever this is along the x-axis and you double it to 16, then along the y-axis that goes from 6. So 8 is related to the 6 here. You double the 6, it goes to 12. And so that is a proportional relationship. You multiply the x value by 2, the y value also gets multiplied by 2. It says, invent a situation that could be represented by this graph. Label the axis, give the graph a title. What could this point right here mean? What does it represent in your situation? So you can choose from any number of stories to describe this graph. You could choose, for example, filling a swimming pool. So it takes time to fill the pool. So it's the amount of water, the volume, given us so much time. You can be traveling a distance. So as you travel a distance, that takes time. So how far have you traveled given a certain amount of time or per time? If you purchase something at the store, how much money are you spending to purchase a certain number of items at the store? Recipe. If you have flour and sugar, how much flour do you use in the recipe compared to how much sugar you use in the recipe? So all of those can be proportional relationships or situations or stories of a proportional relationship. So I'm going to choose purchasing blueberries at a store. I like choosing purchases at a store because it makes sense that to leave the store you have to change everything to dollars, and that's what you pay the cashier. So that idea of the relationship of dollars to the number of things that you're purchasing carries through as you go through the situation. So it says, invent a situation that could represent this graph. So cost of pounds of blueberries. So in this case, they're going to label this point for you, and they're going to say that the x-axis is, I'm going to say that the x-axis is the number of pounds of blueberries. So I'm going to go in, I'm going to purchase a certain number of pounds of blueberries. And again, this is why I like purchasing things at the store. Now you walk up to the cash register. I have 16 pounds of blueberries. And then the cashier tells you how much that's going to cost you. So you need to pay $12 for those blueberries. So you're going to turn, the relationship is pounds and dollars. And you're going to turn these pounds into dollars given this constant of proportionality. So purchase pounds of blueberries. And the constant of proportionality is the cost per pounds of blueberries, or y divided by x. In this case, it's $12 per 16 pounds of blueberries. So that's 12 divided by 16. Well, that 12 divided by 16 simplifies to 3/4. So it's going to cost you 75 cents a pound of blueberries. So if you look at 16 divided by 4 is 4, and 12 is 3 of those 4s. Another way of looking at simplifying 12/16 to 3/4. 3 times 4 is 12, 4 times 4 is 16. So y is always 3/4 of x. So no matter how many pounds of blueberries you purchase, the cost is always going to be 3/4 of that number of pounds. So the cost is 75 cents per pound. So no matter what x is, y, the cost, is 3/4. This is what this tells you. It's 3/4 of, no matter how many pounds of blueberries you purchase, 3/4 of that amount. And so that fits this form of the equation for a proportional relationship of y equals kx.